All right, today we're going to talk about something that has, no exaggeration, completely shaped our modern world: plastic. We're going to trace its whole story, from deep inside the Earth all the way to its really complex and kind of challenging future.
And you know what? I'm willing to bet that's true. Seriously, just look around you right now. The phone in your hand, your computer mouse, maybe the pen on your desk. Plastic is so deeply woven into the fabric of our lives that most of the time we don't even see it.
And a lot of the time, it's hiding in plain sight. You know that paper coffee cup? Yeah, it's lined with a thin layer of plastic. The clothes you're wearing right now, there's a good chance they're woven with plastic fibers like polyester. It is, quite simply, everywhere. So where did it all come from?
Well, to answer that, we've got to go way back in time. And I mean way, way back. Millions of years, actually. Long before people were even around.
The story of plastic really begins deep underground. The very same stuff, that ancient, compressed organic matter that gives us crude oil and natural gas, is also the key ingredient for almost all the plastic we use today. It's a material that's literally born from ancient life. So how exactly do you turn that ancient goo into, say, a water bottle? Well, it's a huge industrial process. First, you've got to get the fossil fuels out of the ground. Then, in a giant refinery, the crude oil gets heated up, which separates it into different parts. One of those parts, a liquid called naphtha, is then sent to what's called a steam cracker. There, it gets blasted with incredible heat. We're talking over 800 degrees Celsius, which shatters its molecules into smaller, simpler pieces. And those pieces are our building blocks.
Right. The small molecules created in the cracker, they're called monomers. And this is a great way to think about it. If plastic is the building, these monomers are the individual bricks. The final step is called polymerization, and that's just the fancy word for chemically linking all those bricks together into these incredibly long chains. And those chains, that's the polymer. That's plastic. Okay, but that raw polymer isn't a finished product, not by a long shot. It's usually made into these tiny little pellets, which then get shipped off to factories all over the globe to be melted down, molded, and transformed into the millions of things we use every single day. And this is where the sheer versatility of plastic really comes into play. By using different kinds of monomer bricks and linking them up in different ways, we get a whole bunch of different plastic families, and each one has its own special properties. You've got PET, which is strong and clear, perfect for soda bottles. Then there's PE, which is super flexible and light, so we use it for plastic bags. And PVC, which is rigid and tough, becomes our pipes. Each one is totally tailored for a specific job.
But wait, there's more. Manufacturers then mix in a whole cocktail of chemical additives to fine-tune the final product. These additives are what give plastic its color, or make it bendy or super hard, or protect it from the sun, or even make it resistant to fire. So a black phone case and a clear water bottle are totally different, not just because of their base polymer, but because of that specific recipe of additives mixed in.
And this brings us to the great paradox of plastic. I mean, think about it. We've engineered this incredibly durable, resilient material that's designed to last for centuries, and then we use it to make things that we throw away after just a few minutes. So, the big question is, what happens next? Because here's the thing. Figuring out what to do with plastic once we're finished with it has become one of the biggest environmental challenges of our time. The journey doesn't just end when we toss it in the bin.
Now you might be thinking, well, I recycle, and that's great. But if you look at the global picture, it's pretty sobering. Despite all our efforts, only a tiny fraction of the world's plastic actually gets recycled. The vast majority of it ends up in landfills, gets burned for energy, or, even worse, escapes out into the environment.
So why aren't we better at this? Well, it turns out that recycling plastic is just incredibly complicated. For one, you can't just melt it all down together. Those different plastic families don't mix. A little bit of leftover food or the wrong kind of label can contaminate an entire batch and ruin it. And get this, every time you melt and reform plastic, its quality gets a little bit worse. It just doesn't work forever.
Right now, there are two main approaches. There's mechanical recycling, which is the most common one. It's basically just shredding, washing, melting, and reforming the plastic. It works, but it has its limits. Then there's chemical recycling. This is an emerging technology that actually aims to break plastics all the way back down to their original monomer bricks. The idea is you could then use those to make brand new, perfect quality plastic. It's really promising, but for now it's super energy intensive and very expensive. And what about all that plastic that doesn't make it to a landfill or a recycling plant? The stuff that escapes? Well, when it gets into our oceans and on our land, it doesn't just go away.
sunlight, and water break it down into smaller and smaller and smaller pieces until it becomes something we call microplastics.
And these tiny particles are now everywhere. They've been found in the deepest parts of the ocean, in our soil, and even in the air we breathe. What's most alarming is that they've worked their way into our food chain and have even been found in human blood. We're still studying the long-term health effects, but it's a stark reminder of just how far our waste can travel.
Okay, I know, that all sounds pretty daunting. It's a huge problem, for sure, but it is not a hopeless one. There are brilliant scientists, policymakers, and innovators all around the world who are actively searching for solutions to tackle this plastic crisis.
And look, there is no single magic bullet here. The real solution is going to be a combination of a whole bunch of different approaches. We're seeing new policies that make companies responsible for the waste they create. Designers are coming up with simpler packaging that's easier to recycle. New tech, like digital watermarks, could totally revolutionize how we sort plastic. And in the world of biology, researchers have even found enzymes that can literally eat certain types of plastic. How cool is that?
Now you might be thinking, what about bioplastics? You know, plastic made from plants instead of oil. It sounds like the perfect solution, right? Well, it's complicated. The promise is huge, but the reality is that many so-called compostable plastics only break down in very specific, high-heat industrial composters, not in your backyard bin and definitely not in the ocean. And if they get mixed in with our regular recycling, they can actually contaminate the whole batch.
And on the biggest scale imaginable, the United Nations is leading an effort to create the first ever legally binding global treaty on plastic pollution. The goal here is to create one unified worldwide plan to manage plastic all the way from production to disposal.
So, as you can see, plastic isn't inherently evil. It's a material of incredible contradictions. It's a miracle that makes modern medicine possible, keeps our food fresh, and helps our cars be more fuel efficient. But that same durability, combined with our throwaway culture, has turned it into a global menace.
The story of plastic is so deeply tied up with our own story. It started with ancient life buried under the sea, and it evolved into a material that has defined our modern world. The challenge for us, right now, is to decide what its next chapter is going to be. Will it be one of more pollution, or will it be a story of innovation, of responsibility, and of creating a more sustainable relationship with this remarkable, complicated material? The next chapter, that's for us to write.